Algebra 2, lesson 10.2, we're going to review SOHCAHTOA. And that's the cool part. Even as you look today, you're going to see that, the sine of an angle, that's your SOH. That's opposite over hypotenuse. Cosine, that's the middle part. The cosine would be A over H. That's the adjacent side over your hypotenuse. And then the TOA, well, that's tangent of an angle. That's opposite over adjacent. So your angle here is x. Okay, you've got x given to you. You can see this little angle ring. And guys, what you want to do to get started is label all of your sides. Let's label all of your sides. So which letter would be opposite of x? F. That would be F, right? And then your hypotenuse would be right across. That's D. Then we've got adjacent, okay? So now at this point, what you're going to do is you're going to say your sine of this angle. You can see we've written this over here. Opposite over adjacent. F over D. Yep, it's F over D. Now, realize Alex will give you some problems where you're going to actually have to write ratios with variables, with letters. And that's perfectly okay. Ratio is a fraction, right? Cosine of x. That's adjacent over the hypotenuse. That's E over D. And then finally, tangent of x. Well, you can see right here that's opposite over adjacent. That would be F over E. So you did that yesterday, believe it or not, and you'll get some more review with that today as well. Guys, the most famous theorem in geometry was the Pythagorean theorem, and it only applies to a right triangle. And what you've probably seen in the past is that you'd have A, B, and C written out, and C was the hypotenuse. And you could say A squared plus B squared would equal C squared. But what Mr. Olson put in the notes is even more accurate and more appropriate, because it's saying it's the leg squared plus the leg squared would equal the hypotenuse squared. Now, what you will be asked to do right here for this next problem is you're going to be finding a missing side. Now, I'm going to just temporarily put in a variable, and you're going to have to get an answer either as an integer or as a square root, as a radical. But which of those three sides is your hypotenuse? Which one do we have here? This would be x. Always find your hypotenuse first, and then go ahead and start writing it out. You'll say x squared, that's your hypotenuse squared, would equal 6 squared plus 8 squared. From here, if you just squared 6 squared is 36, 8 squared is 64, and of course right now 36 plus 64 is 100. Now you could get help with that on the calculator if you're adding big numbers. And then you're going to take just a positive square root, guys. Very important. You can't have a negative side length. And sometimes you're going to see plain and simple that you've got an integer. And that's going to happen a lot. It's going to happen most of the time for these problems. And you're going to get a 10. Now, if you ever get a decimal, then you're going to have to just leave your radical the way it is. We're not going to go to a decimal answer for any of these.
So it stays in a radical?
It would stay in a radical. So, like, for example, if it would have been 97, the square root of 97, we would have left it as the square root of 97.
We're leaving it at square root of 100 or 10?
Well, no, if it's a square root of 100, if it works out to a whole number, then you write that answer down. Let's do part B and find out what x is here. What's the hypotenuse?
7.
That's 7. You got to find your hypotenuse first. Okay? So get that hypotenuse isolated. And if you do that, you're well on your way to getting this right. Okay, it's where the 90-degree box points. Now 7 squared, you can know is 49. And this is 4 squared is 16. How do I solve for x squared? What do you think we got to do? Subtract a 16, right? And you'll get 33. And at this point, we're going to take a square root. But notice the big difference here. If you take a square root of 33, it's not a whole number. Okay? It's not a whole number. So don't write 5.4. Your answer is just the square root of 33. So please keep that in mind. We had a teacher jump ahead by a day, and this is an issue that kids were getting wrong on the homework. Some kids were writing down the decimal answer, and you don't want to do that. Sometimes kids went back to part A, and they'd write the square root of 100. But if your square root breaks down to a whole number instead of a decimal, then you got to write that simplified whole number. Okay, so either a whole number, or if your radical gets you a decimal, leave it just as the radical. Last problem of the day. They're asking you to find sine. And when you're trying to find sine, guys, if we went back to SOHCAHTOA, sine was the SOH. What was the definition of sine? What fraction? Opposite over hypotenuse, right? It's opposite over hypotenuse. Here's the problem. They're not giving you all three sides. So we've got to work this out. Look, from here, which side is opposite in this triangle? It's from theta. That's your 7. How about 4? 4 is adjacent. And the hypotenuse, they didn't even tell you. Okay, that's part of the problem. You'd say, wow, I'm not getting that. Well, you've got to find the hypotenuse to be able to finish this problem. So I'm going to do the Pythagorean theorem. I'm going to write x squared equals 4 squared plus 7 squared. And 4 squared is 16. 7 squared is 49. And from here, we can go 16 plus 49. And you can say it's 65.
That's it.
Now, do I say my hypotenuse is 65? You got to take a square root. So now at this point, the square root of 65, is that a whole number? No, it isn't. So you've got to leave your answer with this radical. Okay, you're going to have radical 65. So sine, like we just said a minute ago, it's the opposite side. What number goes for opposite? 7, right? The hypotenuse is radical 65. It's okay to leave your answer with a radical in the denominator. Some of you have heard you have to rationalize in the past. You don't have to do that here. You can leave your answer with the square root in the denominator. So that's going to be our lesson.